All right, in this video, we're going to be discussing midpoint. Our essential question is, how is the midpoint of a segment on the coordinate plane determined? LaTanya is decorating her living room and draws a floor plan to help look at placement. LaTanya wants to hang a picture at the center of the back wall. How do you find the point at the center between A and B? So if we're trying to find the halfway point between A and B, there's a couple of ways we can do this. One of the way we can do it is we can find the distance between A and B and then find half of it. So A is at 1 on our x-axis and B is at 12 on the x-axis. So we could find the distance by taking 12 minus 1. So we know it's 11 units between A and B. And then we can find half of that, which would be 5.5 units. Then we can count 5.5 units in either direction from A or from B. So from A is at 1. So 1 plus 5.5 units would put me at 6.5 on the x-axis. That's one way we could find the halfway point between A and B. Another way to find the halfway point would be the average the coordinates. So we can find the average of the x coordinates for A and for B. So A is at 1 and B is at 12. So to find the average, I could add these together and divide by 2. And 13 divided by 2 is 6.5. So that's another way we could locate the halfway point of 6.5 between A and B. So that tells me that the halfway point between A and B on my coordinate grid is the point 6.5, 10. LaTanya wants to place a lamp halfway between the chairs at points C and D. How can we find the point where the lamp should go? Well, we could draw a line from C to D and try to figure out where the halfway point between that line is. We could find half of the horizontal distance from C to D. C is at 9 and D is at 11 on the x-axis. So we could find halfway between 9 and 11, which is 10. And we could find half of the vertical distance between C and D. C is at 9 and D is at 5. Halfway between 9 and 5 would be 7. So we could find the halfway point between these by finding half of the horizontal distance and half of the vertical distance and putting those two together to find 10, 7, which would be halfway between C and D. Consider 2 points on the coordinate plane P with coordinates x1, y1 and Q with coordinates x2 and y2 as shown. If we're trying to find the halfway point between these points horizontally, we're trying to find the halfway point between P and X here in my diagram. Somewhere here is going to be the midpoint horizontally. Well, the y value is not going to change. The y value of this coordinate is going to be y1. But what's the x value going to be? How are we going to find out where this is horizontally? Well, it's going to be the average of the two x values. So if we're trying to find the coordinates of this point right here, it's going to be x1 plus x2 divided by 2. We would average those x values. And the y value is just going to be the same, y1. Similarly, if we're trying to find the halfway point between P and Q vertically, the x value is not going to change. So I know the x value of my halfway point between P and Q vertically is going to be x2. And the y value, again, is going to be the average of the y values. So we're going to do y1 plus y2 divided by 2 to find the average of the y values to find the halfway point vertically. Now consider if the segment is diagonal. What are the coordinates of the point halfway between these endpoints? So now we're going to find the halfway point, or the coordinates of the halfway point between P and Q. To do this, we're going to use the x value of the halfway point between the 2 points horizontally, and we're going to use the y value of the halfway point between the 2 points vertically. So we're going to combine what we learned in the last 2 examples to find the halfway point between these 2 points diagonally. To do that, we'll use the x coordinate, which was x1 plus x2 divided by 2, and the y coordinate of the vertical halfway point, y1 plus y2 divided by 2. So basically, we're averaging the two x and y values. Now we have a formula for finding the midpoint of any 2 points on the coordinate plane. A midpoint of a segment is the point that divides the segments into 2 congruent or equal segments. So the midpoint of any line segment PQ with coordinates P x1, y1 and Q x2, y2 is the average of the x values and the average of the y values. So add the x values together and divide by 2, and add the y values together and divide by 2. Let's take a look at an example. What is the midpoint of segment AB? So up here I have our formula to remind us how to do this. We're going to average the x values and we're going to average the y values. So I'm just going to label my x1 and y1 and my x2 and y2 just so I can keep track a little bit easier. And I'm just going to follow the formula. So the average of the x values will be -3 plus 4 divided by 2. And the average of our y values will be 2 plus -2 divided by 2. And -3 plus 4 is 1. 1 divided by 2 is 1/2. And 2 plus -2 is 0. 0 divided by 2 is 0. So our midpoint is going to be found at 1/2, 0, which is right here. Those are the coordinates of our midpoint. Okay, let's give it a shot. Here are some examples of a couple of points on the coordinate plane, and we're going to try to find the midpoint in between them. I would suggest that you pause the video at this time and try these examples to see if you can do them on your own before you see me work them out. All right, so finding the halfway point between points C and D, I'm going to average the x values and I'm going to average the y values. So my x coordinate is going to be -2 plus 8 divided by 2, and my y coordinate is going to be 5 plus -12 divided by 2. This gives me 6 divided by 2 and -7 divided by 2, which is the point 3, -3.5. There's our midpoint. Hopefully you got that one right. Next one, halfway point or the midpoint between E and F. Again, I'm going to average my x values. So this is 2.5 plus -6.2 divided by 2, and -7 plus -3.8 divided by 2, which gives me -3.7 divided by 2 and -10.8 divided by 2, which gives us the point -1.85, -5.4. Okay, consider this challenge problem. The endpoints of a line segment are located at the points x, y, and -7, -4. The midpoint of the segment is located at -3, 3. Create a method to find the coordinates for the missing endpoint. So here we are missing one of the endpoints. We know the midpoint and one of the endpoints, but one of the endpoints is missing. We can still use our midpoint formula to help us find our missing endpoint. So I know I'm going to call this one x1, y1, and I'm going to call this one x2, y2. So I'm going to use this formula and what I know about the midpoint to solve this. So I know that my x coordinate is going to be x1 plus -7 divided by 2, and I know that that's -3. So I can create an equation here that I can solve to find the missing x coordinate of the endpoint. So if I multiply both sides by 2, I get x1 minus 7 equals -6, and then I can add 7 to -6 to find out what my x1 is. x1 is +1. Likewise, I can do the same with my y coordinate. I know that y1 plus -4 divided by 2 is going to equal 3, because that's where the y coordinate of the midpoint is. And I can solve this. So I multiply by 2, y1 minus 4 equals 6, and add 4 to find y1, and that's 10. So I know the missing endpoint is at 1, 10. We can also partition a segment, which means we can find the coordinates of a point at any ratio along that segment, not just halfway. So consider this example. What are the coordinates of the point 3/5 of the way from A to B? So from A to B, we want to know what the coordinates are of the point that is 3/5 of the way there. So the first thing we're going to do is we're going to find 3/5 of the horizontal change and 3/5 of the vertical change. So to find the horizontal change, we're going to take 3/5 times the distance horizontally between A and B. So to find the horizontal distance, we're going to take x2 minus x1. So we're going to find 3/5 of that horizontal distance, or 3/5 times 13 minus 3, which would be 3/5 of 10, which would be 6 units. So 3/5 of the horizontal change is going to be 6 units. To find the vertical change, we're going to do the same thing, but we're going to find 3/5 of the the vertical distance. So we're going to find the vertical distance between these 2 points, which would be 11 minus -4, or 3/5 times 15, which is 9 units. So 3/5 of the vertical change is 9 units. So the next step will be finding the actual coordinates of these. We know that we need to go 6 units to the right, and we need to go 9 units up. So where would that be from point A? Well, we're going to add our 6 units to our x value. So that'll move us 6 units to the right, which would be 9. And we're going to move 9 units up from -4. And -4 plus 9 is 5. So the point on this segment that is 3/5 of the way from A to B is going to be located at 9, 5, which would be right here. That point is 3/5 of the way from A to B. All right, so here are another couple examples that I'd like you to try. So again, pause the video and see if you can figure these two out on your own. Be careful on question B. That's asking for 4/5 of the way from B to A. So it's kind of working backwards from B to A. So consider how you might do that instead of the distance from A to B. All right, so to find 7/10 of the way from A to B, again, I'm going to find 7/10 of the horizontal distance, which would be 7/10 of x2 minus x1. So again, that's 13 minus 3, which is 7/10 of 10, which is 7 units. And then I'm going to find 7/10 of the vertical change, which would be 7/10 times 11 minus negative 4, which is 7/10 of 15, which is 10.5 units. So now to find the coordinates of this point, I'm going to add the change or the number of units to the coordinates of A. So the x coordinates, I need to move 7 units to the right. So 3 plus 7 equals 10. And I need to move 10.5 units up. So negative 4 plus 10.5 equals 6.5. So the coordinates of my point that is 7/10 of the way from A to B is going to be 10, 6.5. 10, 6.5. So there's the location of our point. That is 7/10 of the way from A to B. Okay, so now consider example B. We're trying to find 4/5 of the way from point B to point A. Now we're going to do it very similarly, but we're going to be subtracting our change from B since we're moving backwards from B to A rather than moving to the right from A to B. So we're still going to find the horizontal change. So 4/5 of the distance between A and B horizontally, which would be 4/5 times 10, which is 8 units. And then vertically, we're going to find 4/5 of that change, which again is 11 minus negative 4. 4/5 of 15 is 12 units. So now instead of 8 units right and 12 units up, we're starting at B and working back to A. So I need to go 8 units left and 12 units down. So I'm going to be using the coordinates of B and subtracting. So 8 units left would be 13 minus 8, which is 5, and 12 units down would be 11 minus 12, which is negative 1. So our coordinate that is 4/5 of the way from B to A is 5, negative 1, which would be right here. That is 4/5 of the way from B to A.